Hey kids, our project is on particle movement. First you need to know that s of t equals position, v of t equals velocity, or s prime of t, and a of t equals acceleration, or s double prime of t, or v prime of t. Great. Given an acceleration function, you can use the integral at a given time t value to calculate position or velocity. Given a position function, you can use the derivative of velocity and acceleration at a given time, or t value. Derivative. For example, s of t equals 5.6 t cubed plus 2t squared minus 3t plus 6. If you want to know either acceleration or velocity, you should use the second or first derivatives respectively. Note, v of t equals s prime of t. So, v of t equals 16.8 t squared plus 4t minus 3. Given a t value, you can find the velocity. Ding! Flip the page. Say t equals 6. Velocity would then be 16.8 6 squared plus 4 6 minus 3, which equals 121.8. If you want to find the acceleration, you would find the second derivative, or the derivative of the velocity function. This would mean that v prime of t equals 2 times 16.8 t plus 4, which would be 33.6 t plus 4, which would mean that a of t equals 33.6 t plus 4. I'll write this out for you so you know what to do. Bam. Given t equals 6, then a of t equals 33.6 times 6 plus 4, which equals 205.6. While on the other hand, when given an acceleration function, we can work backwards with integrals. Stay with me, kids. Given a of t equals 15t plus 19, v of t equals the integral of a of t to d of t, which would mean that the integral of 15t plus 19t d of t would be 15t squared over 2 plus 19t plus c. For those of you keeping up, great job. To proceed from here, we must know what the velocity is at a given time in order to solve for c. What is c, you ask? Well, I'll tell you. Given that v of 3 equals 6, it would be 15 times 3 squared all over 2 plus 19 times 3 plus c equals 6, which would mean that 129.5 plus c equals 6, which would mean that 118.5 equals negative c, which would mean that c equals negative 118.5, which would mean that v of t equals 15 halves t squared plus 19t minus 118.5. Got that? Great. S of t equals the integral of v of t to dt, which would mean that the integral of 15 squared over 2t plus 19t minus 118.5 times dt would be 15 over 6 t cubed plus 19 over 2 t squared will be 118.5 t plus c. To proceed once more, we must again be given a value of the function at a corresponding t value. Given that s of 0 equals 6, would mean that 15 over 6, 0 to the third plus 19 over 2, 0 squared, minus 118.5 times 0 plus 6 equals 6. If c equals 6, then s of t would be 15 over 6 t cubed plus 19 over 2 t squared minus 118.5 t plus 6. Feel free to take notes at any time. Now, given any value of t, one can calculate the instantaneous velocity and/or position. You're welcome.